Hello everyone, this is Alan Farsad greeting from beautiful Santa Barbara. Today I am going over soil moisture lab setups. These equipments are used for moisture retention characteristic curve. It is one of the most important products that we make. We have several product options. People have many questions, so I thought I need to make this video and go over the basics of our lab setups. So let's jump right in. Okay, here is a picture of lab 123. It has a longer part number, but that's kind of the nickname of the lab setup. As you can see here, we have three types of extractors in this picture: a 3-station pressure manifold, and there is a compressor that you cannot see in this picture. This is a typical moisture retention characteristic curve. This is what you can generate with our lab setups. Different types of soil here: sand, clay, clay loam, peat. What this curve tells you is how much moisture you have at any specific soil tension level. In order to make this curve, you have to condition your soil at a certain soil tension. For example, let's say at 10 kilopascal or 100 kilopascal of pressure or tension, and then measure moisture content at that tension level, and that gives you 1 point. Now you need at least 6 to 8 points to be able to create it. Sometimes you come up with more points, even better. And the other thing is that your pressure range might be different. Sometimes it's from 0 to 1 bar, sometimes 0 to 5 bar. And if you are doing the whole range in agriculture, is 0 to 15 bar, which basically is known as permanent wilting point. Most plants and crops die at that point, so there's no point for going beyond that pressure. That is why our extractors can go up to 15 bar maximum. We also have an extractor model 1020 that goes to 100 bar. It is used in other branches of science. We have a lot of customers in construction, research, soil physics labs, so they might want to go beyond 15 bar. Okay, so let's look at an extractor closely, and I will explain how a measurement is done. Our lab equipment are basically used for conditioning the soil sample at a certain soil tension. For example, if you would like to condition your soil sample at 1 bar of pressure or tension, better say, in other words, you want the soil moisture of your sample to be at 1 bar of tension, this is how you do it. You put it in a pressure extractor that we saw in the beauty picture. So this is a pressure extractor, and then there's a ceramic plate, actually up to 4 ceramic plate can be placed in our regular extractors. So you saturate your sample, place it over the ceramic plate, and now you apply 1 bar of pressure to your extractor. Because your sample is saturated, it starts draining, but at some point it stops draining draining water. At that point you say, okay, my sample has come to equilibrium with the pressure. In other words, you can say that the moisture level of your sample is at 1 bar. Okay, you can open the extractor, take off your sample and weigh it wet, then dry it and weigh it dry, and come up with your moisture content. Sample water content in percent, this is a gravimetric method. is equal to weight of wet sample minus weight of dry sample over the weight of wet sample. Now you just got yourself the first point or 1 point of your curve. You conditioned your soil at 1 bar, you measured the moisture content. Now you can go back to your curve and at 1 bar, okay, how much water I had, 10% in the sandy soil, and that's 1 point of your curve. And you can keep going, 2 bar, 3, 4, and so on and so forth, and generate more points for your curve. What I just explained to you is actually a pressure method. So in a pressure method, you have 3 major components. One is a pressure source, the other one is a pressure regulating system, and the last part is a pressure extractor. Inside the extractor, you have a ceramic plate and your soil sample. The practical range of application for pressure method is from about 3/4 of a bar to 15 bar. For tensions less than 3/4 of a bar, you better use a vacuum. In this slide, you see a vacuum method. A vacuum method is very similar to a pressure method, except that so this is the pressure method and this is the vacuum method. In vacuum method, there is no extractor. The sample is open to ambient air, and instead of applying pressurized air, you apply vacuum to the drainage port of the ceramic plate. Or it can be a sandbox. Basically, in vacuum method, your sample is over a tension table, as they call it. And so the tension table can be sandbox tension table for tensions very close to saturation, very small amount of vacuum, basically between 0 and 0.3 bar, and then from 0.3 bar up to 3/4 of a bar, you'll use a ceramic tension table. The procedure is very similar. So you start with a saturated sample over a saturated tension table, start applying a regulated amount of vacuum, and once the sample comes to equilibrium with the vacuum level applied, in other words, when your sample stops dripping water or draining water, then you go ahead and remove it from the tension table, weigh it wet, weigh it dry, and basically calculate the soil water content. And that would be another point for your moisture retention characteristic curve. You can apply vacuum using a hanging water column, which is basically just a hose or tubing filled with water. The weight of hanging water column generates a certain amount of tension. The level of tension is equal to the height of water in your hanging water column. So a hanging water column is a very simple and elegant way of applying tension, but it has its shortcomings. The most important problem with a hanging water column is that its range of application is limited, because you need to elevate your sample in order to be able to apply vacuum. In other words, or for example, if I would like to apply 0.3 bar of vacuum, I have to elevate my sample, the whole system, by 3 meter or 15 feet, which it may or may not be convenient for people. We have a low tension lab in Soilmoisture. We have recently developed this. This is basically a hanging water column. It is optimized for maximum convenience and accuracy. Our low tension lab has three major components. One is the plates or the plate assembly, the other one is the hanging stand, and the third part is the shelf. In this picture you see three sets of hanging water column, three tension tables with three hanging columns. We have another option of this product that has the shelf and just one tension table and hanging water column stand. Now, if you are after a more convenient way of doing the vacuum method, you can always go with a vacuum regulating or vacuum manifold. All right, let's take a look at this system and let me tell you what you're looking at. This is again a vacuum method, but here this is your tension table that can be a sandbox tension table or a ceramic tension table. And then there is a water trap assembly. Then there is your vacuum manifold, a vacuum tank, and a vacuum source. This pump is called 2008 F1. This is a vacuum pressure pump that is automated. You can adjust vacuum or pressure level and it automatically sustain the level of pressure or vacuum for you. And this is a precision vacuum manifold that can be 0 to 0.4 bar for very precise vacuum application, or it can be from 0 to 1 bar for the whole range of vacuum that you can apply to your samples. So here's the interesting part. What I did, I put our system options basically on an axis of numbers or axis of pressure. So the first question that you want when you're buying lab setup is that what is my pressure application range? That once you're clear there, then the rest is pretty much obvious and you will know what lab setup you have to obtain. Let me go over our different options quickly. Here you have the pressure method and here you have the vacuum method. In pressure method you have lab 1, which is this guy, lab 2, which is this guy, and lab 3, and lab 1250 and lab 1425 that I'm gonna show you the pictures in the next slide. But our major lab equipment are these three guys, lab 1, lab 2, and lab 3. As you can see, lab 1 and lab 2 have the same pressure application range. The reason is that lab 1 is for swelling clay, shrinking swelling clay, so it's kind of a special type of lab setup. It uses a cellulose membrane instead of using now here we're looking at lab 2. Lab 2 takes 4 ceramic plates in it, and over each ceramic plate you can place up to 12 sample ring that are 2¼ inch in diameter and 1 centimeter in height. If you use that sample size, you can place up to 48 samples inside the extractor, which is called, by the way, 1500, and I'm gonna go over this in more detail. So you can run 48 samples at one shot, which is a great number, and it is unique between any competing method, basically. That is why all commercial soil physics lab use our lab equipments, because it's a method that is very good for large quantities. Then you have lab 3, which is from 0 to 5 bar. You want to use this when your range of measurement is not from 0 to 15 bar, but it's from 0 to 5 bar. And people sometimes ask, can I use a lab 2 to do 0 to 5 bar? In other words, when I have a lab setup that can go from 0 to 15 bar, why should I have another one that is a subset of lab 2? The answer is that, as you can see here, you get a manifold here that is a 6-inch diameter manifold that goes from 0 to 15 bar, but here you have the same diameter, 6 inches, now goes from 0 to 6 bar. This is a lot of more accuracy. The short answer to that question is that with lab 3 you get more accuracy in your pressure application. The other advantage is that you oftentimes might want to run both of the extractors together. You have a set that does 0 to 5 bar and another one that does 0 to 15 bar. Okay, now as you can see, I keep saying 0 to 5 and 0 to 15, but the arrow shows half bar to 15 bar and half bar to 5 bar. The reason is, as I said, we recommend that you do not use a pressure method for pressure applications under 3/4 of a bar, or here I just put half bar. That's okay, you know. You can use it in this range, and there is no magic number here. But it is highly recommended that when you are close to saturation, instead of pressure application, you use tension application or vacuum application. Now, before I go over the vacuum options, let me show you some picture of the lab 1250 and lab 1425 in our pressure side. Okay, lab 1425 is our Tempicell system, and lab 1250 is our 0 to 5 bar hysteresis system. The cell here is 5 inches in diameter and 6 inches in height. I have a better picture later on in my next slides, and I'm gonna show it to you, but here is you basically have a pressure source, a pressure tank, an air tank that can be used for pressure and vacuum, and a pressure cell, and of course a pressure regulating system or a pressure manifold that goes from 0 to 5 bar. Here we have 1425, that is a Tempicell system. A Tempicell system, here what we have is 5 Tempicells that are 6 centimeter tall, and can be 6 centimeter, can be 3 centimeter. We have different options. And the diameter is 2 1/4 inch. Tempicells are basically like miniature extractors, miniature pressure extractors. Instead of using this big guy, you use a tiny one. The advantage of a Tempicell is that it is faster in reading, and it's more convenient to do Tempicells. It's a very popular method that the range of application is between 0 to 2 bar. You can use it for pressure application or vacuum application. So perhaps if you are doing some irrigation research, a tempi cell would be a good candidate, because in irrigation studies you don't want to go beyond 2 bar of pressure application, and tempi cell is more convenient, and also you can do both vacuum and pressure. Here I added a lab 1, 2, 3. This is a kind of a combo lab that you can buy from us. What is the difference between buying a separate lab 1, a separate lab 2, and a separate lab 3? The difference is that here you get just one pressure compressor that unfortunately you can't see it in this picture. If you want to have the full house, you want to buy a lab 1, 2, 3 instead of buying each of them separately. This system is called Lab 2-3. It is our best seller basically. It's very popular. Again, there is a compressor here that you'll see later on, but you cannot see in this picture. Alright, let's move on to the vacuum part of the story. As I said, close to saturation from 0 to 3/4 of a bar. You want to use a vacuum method from 0 to 0.15. You can use a hanging water column that you can see here, and I explained it before or earlier in this presentation. Then you can use some system like this one. The source of vacuum is a vacuum pump and a regulator, and lab 9 and something like this. We have lab 9G3, lab 9G2, lab 9G1. What is the difference? Lab 9G3 is a sandbox tension. This is a sandbox in lab G3, lab 9G3. Lab 9G2 is a half bar ceramic plate, and lab 9G1 is a 1 bar ceramic plate. And the range of application you can see here. Now, it definitely worth mentioning that we also have a large tension table that is the largest ceramic piece that we can manufacture in Soilmoisture. It is a 22-inch diameter ceramic plate that is called 1725. Now, this is a system that you can build with 1725. A vacuum source, a vacuum tank, a vacuum manifold, can be 0 to 1 bar, and a water trap assembly, and of course the big guy 1725. 1725 is not shown here, but the range of application can be lab 9G1, lab 9G2 combined. It's a 1 bar ceramic plate. So a 1 bar ceramic plate, the best range of application is here, but you can use it for half bar too. And the reason that these guys have overlap is that each system is tailored or optimized for a certain application. Let me compare lab 09 with 1725 quickly here. Here, as you saw, this is a 12-inch diameter tension table, while lab 1725, as I said, is 22-inch in diameter. So 1725 is more suitable for heavy-duty applications and commercial soil physics labs. The part of the presentation is going over our pressure extract. I have collected all the extractors that we have available here for you and with the range of application. Let me start from left to right. Extractor 1000, and this guy is 1500. 1000 and 1500, the range of application is from 0 to 15 bar. 1000 extractor is used for shrinking swelling clay, and you saw the picture in the previous slides. 1500 is for quote unquote regular soils, and here I have 1600 that the range of application is from 0 to 5 bar, as you can see here. Then I have the hysteresis cell, which is called 1250, the range of application from 0 to 5 bar, and of course our Tempe cells. Model 1400 is this picture that has a 2¼ inch diameter, and model 1405 is 3½ inch in diameter. And last but not least is the model number 1020, which can be used from 0 to 100 bar. Very impressive. The next slide is going over another major component of our lab setups, which is pressure or vacuum manifolds. I have a picture of a pressure manifold here and a vacuum manifold here. You can see the directions of the dials are the opposite of each other, and a pressure manifold has a water filter here while a vacuum manifold doesn't. I would like to talk a little bit about the importance of pressure vacuum manifolds. Pressure vacuum manifold importance or critical role is sometimes overlooked by people. They think that a manifold is only a device for adjusting vacuum or pressure level. Well, that is true, but another even more important role of a manifold is to stabilize the pressure or vacuum. In other words, when you adjust vacuum, for example, on 0.5 bar, the needle should not fluctuate for the duration of your experiment or measurement campaign. If the pressure or vacuum fluctuates, then the measurement that you are performing does not mean anything. That is why you need to stabilize your pressure. And let me tell you, that is not a simple task. That is why you pay the big buck for soil moisture, pressure, or vacuum manifolds, because these guys can do the job and can stabilize the pressure at the level that you want. And by the way, with a high level of resolution and accuracy. We have several pressure and vacuum manifolds. I will not read all these part numbers, but this slide is very informative, and you can read the part numbers and see what extractor they are used for and what is the range of each manifold. This is basically all soil moisture manifold options in one slide. A very useful piece of information for you if you are thinking about picking parts and pieces and putting together your system. If you are buying a complete system, then good for you. You don't need to add these numbers, although getting familiar with different components, of course, is always puts you in a better position. All right, let's go and take a look at some other slides. I added these pictures just to show you that you can order combo manifolds. Here is a 2-station manifold used for model 1000 extractor, and this part is used for model 1500 extractor. And this manifold is a 3-station manifold that is used for our lab 1, 2, 3. Linking manifolds together make them more convenient to use. You just have one input that goes right to the compressor, and then it feeds all the stations. Basically, you can order a station separately, but oftentimes people prefer to have them as a combined manifold. And if you buy a lab 2-3, you get this guy, and if you buy a lab 1-2-3, you get this combined or combo manifold. Lab setup components, pressure vacuum sources. So you have a 0 to 20 bar pressure compressor that is called model 0505. By the way, this model is going away and we are replacing it with a better compressor that is called 0500. The next one is model 2008 F1, which is from -1 to +10. Here I marked it as -3/4 to +10. The reason is that it is very hard to achieve complete vacuum, but 3/4 of a bar is an achievable level of vacuum. So that is why here you can see that 2008 F1 goes from 3/4 of a bar of vacuum to 10 bar of pressure. The next one, which I put here but doesn't have application in lab setups, is model 2006 G2 or G3. It goes from, again, 3/4 of a bar to almost 4 bar, a very powerful foot pump. Mostly we use it with our soil water samplers. The next vacuum option that we have that is not in our lab setups is 2006 G2. That is only vacuum pump. It's a vacuum. Another source that you can always use for your lab setups is nitrogen tanks. Nitrogen tanks can be rented locally. We do not provide the tanks. We do not rent nitrogen tanks, but we can provide you with regulators that can be used in line with the nitrogen tank and to your pressure manifolds. Okay, next slide is going over extraction medium. Just to refresh your memory, in pressure method or vacuum method, pressure or vacuum medium. And this medium that is shown in yellow color here acts basically like a filter, but it also has a kind of property to it. And let me explain. For example, you put your saturated sample on a tension table, and as I said, you start applying vacuum to the vacuum port, and water goes from your sample into the sandbox or into the ceramic plate and drains out of the system. But have you ever thought that why air doesn't get into your tension table? In other words, if I apply vacuum to the vacuum port, why air doesn't get into your plate, and why air doesn't get into the drainage port? That is really interesting if you think about it. But that is the property of the tension table or ceramic plate. In other words, water can go, but air cannot go through it. And that is the whole reason the system works. Soilmoisture Equipment Corporation is very famous and is actually the gold standard of creating or ceramic plates. And because the ceramic plates have this magical property that I just explained, basically they are sealed to air, but they are permeable to water. Everybody is after soil moisture products. We have 8 different types of ceramics. The different is, well, obviously in the recipe, but also in the air entry value. We have 1 bar ceramic, 2 bar ceramic, 3 bar, 5 bar, and 15 bar. And 1 bar ceramic is used between 5 bar and 1 bar. 2 bar ceramic from 1 bar to 2 bar, 3 bar ceramic from 2 bar to 3 bar, 5 bar from 3 to 5, and 15, 5 to 15 bar. And each ceramic has a certain pore size, each ceramic has a certain bubbling point and a certain air entry value, and each ceramic has an application range. Now people might ask, okay, and I get that question often actually. People say, oh, I have a 15 bar ceramic. Can I use it from 0 to 15 bar? In other words, why should I use 1 bar, 2 bar, 3 and 5 bar ceramic when I have a 15 bar ceramic? The answer is that if you use a 15 bar ceramic for 1 bar pressure application, because the pore size of 15 bar ceramic is very small, no water drainage is going to happen. The ceramic doesn't even feel. That is why the range of application is from 5 bar to 15 bar. Again, this slide is very useful in terms of pressure application range of our ceramics. That is a very common question that I get almost every week at least. Here, let me explain a little bit about high flow and standard flow options. Sometimes people ask, Soilmoisture has 1 bar standard flow and 1 bar high flow. What is the difference? Well, the difference is the flow rate. 1 bar high flow has 10 times more flow rate. Now the next question is that, then why should I use a standard flow? The answer to that question is that, well, oftentimes you don't have to. 1 bar high flow has been invented after 1 bar standard flow, and that is why it is better. It has more flow rate, and that is why we have 2 types of ceramics. Maybe we should have obsolete 1 bar standard flow, but because it has been in numerous publications and other scientific sources, people still are asking for it, and that's why we are still making them. In this picture you can see a ceramic plate. This is a tension table, 12 inches in diameter, and this is 1725, a tension table that is 22 inches in diameter. The application of ceramic plates, half bar ceramic in vacuum application, you can see here from 0.1 to 0.5 bar of vacuum, and a 1 bar ceramic plate which looks exactly the same as half bar, but it's just different porosity. The application range is from 0.4 bar to 3/4 of a bar. The last slide is going over Soilmoisture lab setup systems. This is the pressure system. Just to reiterate what we said in this presentation, a pressure system consists of a pressure regulating system or a pressure manifold and a pressure extractor, while a vacuum method consists of a vacuum source, an air tank, a vacuum manifold, a water trap, and a tension table. Let me just add one last thing here before I forget. The pressure method also has a pressure tank, but you cannot see it here. It's a small pressure tank in model 0505. Actually, our new our new compressor model 0500 has a much larger pressure reservoir that is a much better option for our users in future. It's going to be released in near future. You cannot see the air tank here, but it's built in 0505 compressor. And by the way, that air reservoir or air tank can go up to 20 bar. The nominal range of it is 20 bar, while a regular tank that you buy in market can go up to just 8 bar. So please do not use a regular air tank in line with your pressure lab setup, because our compressor can generate 20 bar of pressure, which is well beyond the application range of a regular air tank. Our vacuum has a big label that says that the tank should not be used for pressurized application beyond 8 bar, and it also has a safety valve. Our air tank has a safety valve. The model number is 1980 and the color is blue. Here is gray, but the standard color is blue. Let me see. I guess I have the picture here somewhere. Yes, just to show you, this is our 1980 air tank that the application range of it is from -1 bar to +8 bar of pressure. Okay, with that being said, our presentation comes to the end. Thank you for watching. If you had any questions, you can email us. Our email address is sales@soilmoisture.com, or you can call us. The telephone number is 805 964 3525. This is Alan Farsad. Thank you for watching. Goodbye.